My name is Matt Jones. I'm a graduate student in the Earth and Planetary Science Department. I work with Brad Sageman. And I'm really glad to have the opportunity today to talk a little bit about my research. I've been interested in climate change for so long, probably since reading books about it in high school, so it's great to present on my research. And the question that I'm focusing on in my research is, did ancient CO2 emissions drive ocean acidification and marine extinction events? And I'm a geologist. I study sedimentary rocks. What I'm doing is I'm looking for analogs to modern climate change by going back and studying the rock record. And the basics of the science are pretty simple. Younger sediments and rocks get deposited on top of older rocks. So if you walk up through a section, through a cliff, or through an outcrop, and if you make careful observations at every different level that you're moving through, you can actually come up with a story of how climate has changed through the past. And one of my main goals of research is trying to find an analog to modern climate change. And one of the best ones that I've come across, and I've had the opportunity to study here at Northwestern, is Oceanic Anoxic Event 2, which was roughly 94 million years ago. It was a long time ago, much different world at that time. There was actually a seaway that stretched between the Gulf of Mexico up to the Arctic waters that you can see on the map here. And when you study the sediments that are left over from this seaway, you can actually find a lot of really interesting facts about climate and this event in particular. And the first is that CO2 rates in the atmosphere, CO2 concentrations spike right at the onset of this event. We also find that there's a lot of warmth on the planet at that time. We find turtle fossils from the Arctic, so that's kind of crazy to think about in itself. And then we also find evidence for coastal flooding. If you look in this picture, you can see that there are coals at the base, and then as you move up to younger and younger, all of a sudden you hit this horizon where there's flooding across the top and you get an oyster bed. So that means you're offshore. So there's a CO2 pulse, warming, and flooding. And in addition, there's an extinction in the marine ecosystem. 93% of ammonites go extinct. You guys might be familiar with some of those if you've been to the Field Museum before. They're the little coiled cephalopods. And additionally, other organisms go extinct further down in the food web, so closer, microscopic organisms. So, okay, to recap, we have a CO2 emission event, we have warm temperatures, we have flooding, and we have an extinction event. Perfect. Well, not perfect, but you get what I'm saying. It's a good analog for today's situation. But there's still some questions remaining, so that's the goal of the research that I've been involved with, is how exactly did this extinction manifest itself? We know that we transitioned into a very high CO2 event, but there are a bunch of different ideas on what could have caused this extinction to occur. Maybe there's less oxygen in the ocean, maybe the ocean's acidified because we had so much CO2 going into the atmosphere, or maybe it's something else that we have to consider. And at Northwestern, our group is focusing on acidification as a possible hypothesis for this extinction. So to actually test this hypothesis, we went to Utah this summer. Here's a photo by Monica Nook from ISEN. We were out there with a whole bunch of different people collaborating on this drilling project. It was a National Science Foundation funded project that brought geologists from Northwestern, Penn State, UMass Amherst, the U.S. Geologic Survey, the Bureau of Land Management, National Park Service. Everybody was collaborating together to try to understand and bring new understanding to this unresolved question in geology. And this is kind of the environment that we were working in with our drill rigs, just to give you a picture of what the Western Interior Seaway, or the remnants of the Western Interior Seaway, look like today. And in addition, we also took samples from the outcrop. This is probably what you guys associate with geologists, picks and hammers and whatnot. Everybody's smiling in this picture and really eager to get going. That's probably because it was taken in the first 15 minutes or so. It was really hot out there. It was over 100 degrees every day and not much shade around, so the second day we brought in reinforcements and continued trenching. But either way, we were able to collect our samples, and so we're moving on to the next phase of the project now. And we're starting to actually analyze fossils from this time to try to see whether or not acidification could have driven them to extinction. And the basic idea is that most shells are composed of two minerals, either aragonite or calcite. And when an ocean or water body begins to acidify, aragonite dissolves first. So if acidification is driving this event, we would expect the organisms that have aragonitic shells to disappear first. Remember, that would be lower in the section, so as we work our way up through. And so that research will be carried out here this coming year. And so at this point, you're probably like, who cares? That was 94 million years ago. There's no ocean in Utah. What is this guy going on about? But when you look at the modern scenario, I think it's quite analogous. We have this rapid emission of CO2 into the atmosphere. And we also have this, this drop in oceanic pH. So these are two signatures of what we can expect from the future. And if you look at projections into the future, of course, there's going to be more carbon being emitted into the atmosphere. And we see that the oceans will continue to acidify. So by being able to go back in the geologic record and answer questions about how the marine ecosystem responded to climate change and CO2 emissions in ancient times, I think that will provide some valuable information for what we have coming down the road. And so this is just one example of some of the research that's going on at Northwestern involving climate and energy topics. And I think it's not enough for us to just stay in our labs and sit on our results. It's great to be able to have the opportunity to come out and share these results. So thank you for the opportunity to do that. Thank you.